I am going to talk about some of the lessons to develop a clean technology startup. One thing that I want to say before we get started, so I do have a bit of a stutter. Sometimes it is going to take me a little while longer to say something, so if you can, please just bear with me. But anyway, just to dive in, here's the problem we are hoping to solve. Most of the apartments that are heated with steam, they are actually significantly overheated. If you run through all of the numbers for all of the apartments in the New York City area, you are going to get a total of over $500 million every year is just wasted from this overheating. So why this is because of the steam systems that are used to heat most of these sorts of buildings. It was a great technology for the time, but since it has been installed, it just really hasn't changed all that much. And if you look at this little cartoon here, you can see one of the major problems is you only have one point of control for the entire building. You can either have the boiler on or you can have the boiler off. You can either have heat or you cannot have heat. How we want to solve this problem is to have an add-on that we can have for the radiators that are in the building to make each of them smarter and more thermostatically sort of controlled. So we have three key components of the system. We have an enclosure that is going to let us turn off heat transfer. We have fans that are going to let us turn heat transfer back on. And we also have a monitoring system so we can decide if we want heat or if we don't. So we started off by seeing if we could actually build something like this and then have it work. So this is actually a system that we built and installed in my co-founder's apartment since he was just sick of the overheating problem. You can see we have a before shot and an after shot showing that the system actually works. And you can see the whole system works pretty well to eliminate the overheating. So we learned some very interesting things from the prototype phase. Two of the points that I want to emphasize is that if you want to solve a problem like this, you first have to do your homework. So for us, that actually meant looking back at the laws of thermodynamics and then seeing how the heat transfer in a building something actually worked. Then the second point, really parallels the lessons of the first talk. Is if you want to make something, you should just go ahead and make something, and then you can get the actual data, which is the best way to show that your idea actually works. So on the strength of the data that we got from the prototype, we were able to get funding from the New York State business plan competition and from Columbia to install a full-scale system, for a pilot. What was nice is we found two very similar buildings side by side, so we could have a control building, as you see on the left, where we just look at the temperature throughout the building, and then we actually have our system installed on the building on the right. So what we found out from the data from our pilot is it is very, very promising data, but it's not quite as good as we would have hoped. So what you can see here is this shows the temperature for all of the rooms throughout the building over a 24-hour day. You can see for the reference building on the left, you have more of the overheating and you have more of the variations of the temperature. On the right, what we showed our system was able to do was to help stop the overheating for some of these apartments and to help smooth out some of the temperature variations. If we look more closely at the data that we have, what we're able to see is that there are just some of the apartments that are too hot for a system just because we couldn't get enough of the insulation in the apartment. There are other apartments that were just too cold because the size of the radiator wasn't large enough. But we did find some apartments where we had the right amount of insulation and the right amount of heat. Then you can see we're actually able to do something to control the temperature there. So then some of the lessons that we learned from the pilot is if you have all the theory that you want, so that's great, but you have to get it out there, have to see how it actually works out in the real world, because there are going to be some things that you just weren't able to see when you're working working back in the lab. So you're going to screw up. You're going to want to be able to make some changes. So you really want to have your pilot set up so you are able to make those changes. One of the most surprising things for us as a group of engineers was to find out that so that we were in the customer service industry now. Since we wanted to install this in someone's home, it is something they are going to want to have in their home. And if they say, I don't like the case because it's black, I don't like the color of the light on this, that is something that you are going to have to listen to and have to take into account. So then where we are now is we have the data from the first pilot that we did. We have determined a site for a second pilot, and so we're now looking to see how we can make a large quantity of these for the next pilot and for eventually for a product. So some of the lessons that we've learned from the development side of things, certainly we have screwed up a lot along the way, and then that's okay. That is just something that comes with the territory. But the moral is you just have to keep on trying and see what you can do. Just have to keep on putting yourself out there. So one last slide. Since this is supposed to be more of an inspirational talk, I decided I would end with some advice for anyone who wants to try their hand at a startup. So the first thing I would say is that you have to have a problem that you're trying to solve. Even if you have the greatest technology ever, if there isn't a market for it, then it isn't going to make for a very good startup. Second, you should take advantage of all of the resources that you can get. So especially if you want to get free money for your startup to fund these kind of projects. Something that is nice is that so far we haven't had to raise any sort of venture capital because we've been able to fund this just through various grants and business plan sort of competitions. So then finally, no one is going to be able to do this all on their own, so you have to have the right team. And with that, I just want to thank everyone. So on my team, my co-founder Marshall Cox is here. Our advisor John Kamissis is also a co-founder. Then I also want to thank Mike, who is our design engineer, who has done all of the real work. So that's it.